Okay, so over the next couple of days, we're going to talk about regressions. So you might recall that you did regressions, but you did linear regressions back in the middle school. You found the line of best fit. That's what we're going to be doing, but we're not going to necessarily be doing lines. So we have to do other types of equations that we dealt with this year. So the log equations, exponential equations, the sinusoidal equation. All right, so but it's basically the same thing. It's all data, inputting stuff into your calculator, basically copying stuff off your calculator and writing the equations and some calculations that go along with it. All right, so let's just take a look at the definition of a regression. Oftentimes in science, a mathematical relationship between two variables is desired for predictive purposes. In the real world, the relationship between two variables is not always a perfect one. Thus, we often look for the best curve that can fit the data. So when you were in algebra, you guys did these scatter plots, and for the most part, the best fit curve was a line. That's why you guys only talked about lines. But sometimes when you have scatter plots, the best fit curve is not a line. Sometimes it is an exponential. So that's what we're going to be working on. All right, so let's take a look at the example. Okay, so the population of Jamestown has been recorded for selected years since 2000. So this is important. You have to know that your years are since 2000. The table below gives these populations. All right, so in the year 2002, the population was 5,564. In 2004, 6,121. 2005, we have 6,300. 2007 is 6,812. And 2009, it's 7,422. Determine a best fit exponential equation. So we're doing an exponential where x, this is important, super important, x represents the years since 2000 and y represents the population. And then when we write our exponential, we are going to round to the nearest thousandth. Okay, so what you're going to do is you need to start plugging things into your calculator. So you're going to go to Stat, go into Edit, and we're going to create two lists. This will be your year, which is time. That's always your list one. Time is list one. And list two will be population. Now, when you plug this into your calculator, since X, this is your X, this is your Y. List one will always be your X. List two is always your Y. Your X, this is, you got to be careful, super important. Your X is the number of years since 2000. So you are not plugging in 2002 into list one. Remember, X is the number of years since 2000. So you should be plugging in 2. 4. 2004. 2005 would be 5. 2007 would be 7. And 2009 would be 9. Okay, so now in list 2, you're going to put in your population. So you have 5,564, and so on, so on, and so on. So plug that into list 2. You don't have to change any of that. All right, so now you're going to hit Stat, go over to Calc. You're looking for the one that says exponential. I think it says EXP regression. Okay, so just scroll down until you'll see the linear, you'll see a power, you'll see the sinusoidal, you'll see a quadratic. So you're looking for the exponential, EXP. All right, so hit enter for that, and it'll say list 1, list 2, you need list 1, you need list 2. Just hit enter, 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 calculate, enter. All right, and then when you get through, you have y equals, you're going to write exactly what's on your calculator screen first, exactly the way it is. All right, because this is your work. Y equals a b to the x power. You're going to write down what a is. You're not rounding anything until we actually write the equation. 5157.9201335. That's a 3. B, 1.041160067. Now, you should have an r squared and an r on there. So R is 0.99701825556, And R is 0.998508148. And there's a zero in there. There's a zero in there. Okay. Now, if you don't have R and R squared on your calculator, you need to put your diagnostics on. So I'm just going to go through this quickly if you don't have R and R squared on your calculator. If you only have the A and Y equals A and the B. So you hit second catalog. It's down by the zero. You scroll through till you get to the D's. When you get to the D's, slow down. You're looking for what says diagnostics. On. Okay, when you get that, just hit enter, it'll say done. Now, what you need to do then to see your R and your R squared is go back to stat, go over to calc, and do the regression, do the regression again. And now you'll see your R and your R squared. All right, so first let me tell you what R is, this guy right here, and then we'll write the equation. So the closer R is to 1 or -1, it has a better fit. Okay, so if it's 1 or -1, it's actually a perfect fit for any type of equation. The closer R is to 1 or -1. So R is between or equal to 1 and -1. It could be 0. If it's 0, that means like if you plotted your scatter plot, they're all just all over the place. There's really no fit for the data. All right, so as it gets closer to 1 or to -1, the points will start to get closer to some type of curve, whether it's regression or a line or an exponential or a line or a natural log or whatever. Okay, so now let's write the equation because I didn't actually write the equation yet. So now you're going to take your equation, y equals a times b to the x power, and you're going to now round to the nearest thousandth, your a and your b, and write the equation. So it's y equals, a is 5157.920 times b, and b is 1.041 raised to the x power. That's your exponential regression equation, and that's the work that you would have to show. The black stuff over here that shows your work, and then the equation with your a and your b rounded in here. Okay, so now let's take a look at the next part. It says, so this is an exponential, so we should realize that there is a percent increase here. And how do we know this is a percent increase? The reason why it's a percent increase, so it's going up, is because it's greater than 1. Remember, if it's less than 1, when you have something like this, 0.057, that means it's a decay. So this is a growth. All right, this is a growth in here because it's greater than 1. So this 1.041 represents a growth. So I want to know what is to the percent growth. So remember, this is a plus, this is 1 plus 0.041. Okay, so remember, this is R plus, not R, jeez, what's wrong with me tonight? This is 1 plus your rate. So your rate is 0.041. So I gotta move this stuff up, looks like. All right, so this is my rate. My rate is equal to 0.041. So to get the percent, you move the decimal 2 places to the right. So it's 4.1%. That's your percent increase. Your population is increasing. All right, and let's look at the last part. So it says, algebraically, determine the number of years to the nearest year. So if I'm determining the number of years, identify what you have to solve for. That means you're solving for x. X represented the number of years. For the population to reach 20,000. Now remember, your population was your y value. So I'm using the equation. Y equals, this is the one that we wrote down before, 5157.920 times 1.041 to the x power. So they want us to find how many years, that's your x, for your population to reach to 20,000. That's your y value. So 20,000 is equal to 5157.920 times 1.041 to the x power. Now you should realize right away at this point in the course that you are solving for an x value and your x value is in your exponent. You should realize right away that at some point you're going to have to use logs. All right, so this is times. To get rid of the times, we'll divide both sides by 5157.920. Both sides. All right, so we get rid of that. So we have 1.041 raised to the x power equals 3.87753228. All right, so now there's nothing else to do because I have this base that has an exponent. Now we use log, so it's a log 3.87753228 equals log 1.041 raised to the x power. Remember the rule for an exponent goes into the front, so it's log 3.87753228 equals x log 1.041. And now we'll divide both sides by log 1.041, log 1.041. Okay, so we get x equals, just plug it into your calculator, 33.726. It says to the nearest year. So it will take 34 years for the population to reach 20,000. If it asked what year, you would take that, right? And remember, x represents the number of years since 2000. So that would be in 2034 if it asked what year. All right, but it will take 34 years. Okay, so that's it. And we'll practice some more tomorrow in class. And I'll show you actually how to put the scatter plot on your calculator. So just remind me tomorrow. Okay, have a good night.